Hello, in this video we are going to see the lesson for grade 12. The lesson name is electrochemistry. Under this electrochemistry lesson we are going to see the topic galvanic cell. So before going to the galvanic cell, we should know what is a electrochemical cell. An electrochemical cell, it is a device which converts chemical energy into electrical energy, or else it can convert electrical energy into a chemical energy. And it is classified into two types. One is a galvanic cell, another is an electrolytic cell. First, let's see what is an electrolytic cell. An electrolytic cell is a device which converts electrical energy into a chemical energy. So that is, it takes a electrical energy from the external source, and this reaction is a non-spontaneous reaction. So basically it converts electrical energy into a chemical reaction. So to undergo a chemical reaction, we are supplying an electrical energy. So that is your electrolytic cell. Next is your galvanic cell. So it is a device in which the reaction is spontaneous, and this reaction is a spontaneous chemical reaction. So by this chemical reaction, electrical current is produced. So basically it converts chemical energy into electrical energy, and it is commonly known as battery. So galvanic cells are commonly known as battery. So we are going to see a Daniell cell, which is an example for galvanic cell. So in Daniell cell, it consists of two half cells. So one is a cathodic half cell, another is a anodic half cell. So the two half cells are connected through a Zoll bridge, which helps in the flow of electrons. First, let's see about the oxidation of cell. So oxidation is nothing but a giving up of electrons. That is a oxidation. And here oxidation takes place at an anode. So in the oxidation of cell, a zinc metal strip. So look at here, a zinc metal strip is placed inside a zinc sulfate solution. So this zinc metal strip, it acts as an electrode, and this solution, zinc sulfate solution, acts as an electrolyte. These two constitutes a oxidation of cell. And next is a reduction of cell. So that it takes place at the cathode, and reduction is nothing but acceptance of electron to form a reduction is accepting an electrons by an ions. So here in Daniell cell, we are using a copper metal strip. So copper metal strip, which is dipped inside a copper sulfate solution. So this copper acts as an electrode. So here it acts as a cathode, and this copper sulfate solution acts as an electrolyte. Okay, this copper metal dipped in a copper sulfate solution acts as an reduction of cell. Next we are going to see a anodic oxidation reaction. So at anode, oxidation takes place. So what happens is the zinc loses its electron and oxidized as Zn 2+ ions. So look at here, this zinc, this is a representation of a zinc metal. So how the zinc atoms are arranged in a zinc metal. So they are closely packed, and this atom, zinc atom, it loses its electron and forms a Zn2 plus ions and goes into the solution, that is an electrolyte. Now let's see the equation for it. So Zn solid gives Zn2 plus aqueous plus 2 electron. So this is your oxidation. So that is losing an electron. Next, cathodic reduction reaction. So at cathode, reduction takes place. So that is the copper ions from the electrolyte. So look at here. So this is the cathodic of cell where the copper metal is placed in a copper sulfate solution. So in a copper sulfate solution, we have a Cu2 plus ions. This Cu2 plus ions, they gain electron and get reduced and get deposited on this copper metal. So this is taking place in the cathodic reduction reaction. So cathodic of cell. This reaction takes place at the cathodic of cell. And look at the reaction. Cu2 plus from aqueous, it gains 2 electron and forms Cu. This Cu is deposited on the copper metal strip. So this is your reduction reaction. And this is the representation, whole representation of a Daniell cell. So here the two half cell, anodic half cell and a cathodic half cell, are linked together by a salt bridge. So salt bridge, so look at here, this is a salt bridge. It's nothing but a U-tube. So in which we have a electrolyte which was present along with the agar-agar. So along with the agar-agar, we use a electrolyte. These electrolytes are basically non-reactive. The electrolytes which is used as a salt bridge are non-reactive. It contains a non-reactive ions. It won't react with this metal or with this thing. Okay, they will be non-reactive ions. So usually we will use KCl or sodium sulfate salt bridge. Okay, here you are using sodium sulfate. Okay, so what happens is, as the reaction proceeds, so when we place the zinc metal in a zinc sulfate solution at the anode compartment, what happens is the zinc, it loses its electron and goes into the solution. So at the anode, what happens is there becomes a more number of Zn2 plus ions. The ions, positive ions, will be in more numbers. And same way in the cathode, what happens is the Cu2 plus ions from the electrolyte goes into they gains electron and they get deposited on the copper metal strip. So here what happens is the Cu2 plus ions becomes less. So here this negative ions will be in more number. Okay, so at that point what happens is the ions from the salt bridge, so the non-reactive ions, that is sodium sulfate, it dissociates into sulfate ions and sodium ions. This negative ion sodium sulfate ions moves to the anode, anodic of cell, and sodium ions moves to the cathodic of cell. So what happens through this movement, what happens is the electron continues to flow from this, from here, from the cathodic anodic cell to the cathodic cell. Okay, so through the salt bridge, the electrons flows from this anodic cell to the cathodic cell, and we have connected this both the electrode through via voltmeter to measure the current produced. Okay, so for a Daniell cell, it will produce a current up to 1.1 volt. So the E0 value for a Daniell cell is 1.1 volt. So completion of a circuit. So when this zinc get oxidized, the electron from the anode compartments it moves through the cathode compartment through a salt bridge, and hence what happens is the current starts to flow, that is, an electron starts to flow from a anodic compartment to the cathodic compartment, and the circuit becomes complete. So conception of electrode. So what happens in the Daniell cell is, so once the, as long as the zinc moves into the, it goes into the uh, zinc sulfate solution, okay, which was taken in a anode of cell, so the reaction will proceed. Or else the copper ions in the copper sulfate solution, which was taken in a cathodic of cell, so the number of Cu2 plus ions should be decreasing. So when they were consumed continuously, the reaction will stop. So until then, the reaction will proceed. So till the electrodes were consumed, or till the electrolyte were the metal gets deposited on the copper, the reaction will continue. So next is the galvanic cell notation. How will you represent a cell reaction? So how to represent is, first we have to write the anode reaction to the extreme left side, and which should be separated by a salt bridge, that is a double line. We have to draw a double line. Next we have to write the cathode reaction on the right side. So first let's see. So anode reaction. So what takes place at the anode is oxidation. So zinc metal, it gets oxidized to Zn2 plus. So here we have a two phase. One is a solid phase, that is a zinc is in a metal state, that is a solid phase, and it goes into the solution, aqueous phase. So these two phases has to be separated by drawing a single slash. So that is a phase boundary. So Zn solid slash Zn2 plus aqueous. So this is a anode reaction. And next double slash, which is a salt bridge. And next your cathode reaction. So what happens at cathode? The Cu2 plus ions from the solution, so that is Cu2 plus aqueous, it gains electron and deposits on the copper strip. So Cu2 plus aqueous, and then a phase boundaries, that is a single slash, and Cu solid. So at the end of this thing, we can write the how much current is produced. So E naught for a Daniell cell is 1.1 volt. So this is a way to represent a galvanic cell. So some of the example for a galvanic cell. So they have given a net overall reaction. So in a galvanic cell, what happens is a redox reaction takes place. So that is one of it undergoes a oxidation and another of it undergoes a reduction. So look at here, 2 Cr solid plus 3 Cu2 plus aqueous gives 2 Cr3 plus aqueous plus 3 Cu solid. So first we have to write, so before writing a cell notation, we have to write the half cell reaction. First we are going to write a anodic oxidation. So what which get oxidized is chromium. So chromium here Cr gets oxidized to Cr3 plus. So that we have to write this. Okay, 2 Cr solid gives 2 Cr3 plus aqueous plus electron, 6 electron. So it loses 6 electron. So next is a cathode reduction. So copper 3 Cu2 plus in aqueous, it gains those 6 electron plus 6 electron gives 3 Cu solid. So these are the two half cell reaction. So once we wrote the half cell reaction, it is very easy to write the cell notation. So while writing a cell notation, what we have to do is, at the left side we have to write a anode reaction. So in between, while writing anode, we have to give a slash to represent the phase boundary, and followed by that we have to draw a double slash to represent the salt bridge, and followed by a cathode reaction. Okay, so look at the cell notation here, Cr solid slash Cr3 plus aqueous double slash Cu2 plus aqueous slash Cu solid. So this is another example for your galvanic cell. Thank you. We'll meet in the next video.